What if, right now, somewhere in the depths of space, a messenger from humanity is traveling, having already left the solar system? It was launched back in the last century, but it still transmits signals to Earth. This is the legendary spacecraft Voyager 2. During its journey, it flew past the giant worlds of Jupiter, Saturn, Uranus, and Neptune, and showed us space as no one had ever seen it before. But where is it heading now?
How far do you think a modern probe can travel into space in 44 years? What will it see beyond Earth's neighborhood, and what dangers will it encounter along the way? We know the answer to the first question for sure. At this stage, an unmanned spacecraft, created at the end of the last century, can travel about 11 billion miles in less than half a century, an unimaginable distance by earthly standards. This was clearly demonstrated by Voyager 2, which spent many years traversing the pitch-black darkness of the universe. And you wouldn't believe how many Western mysteries the little space scout uncovered during its journey. Equipped with a multitude of scientific research instruments, Voyager 2 gave astronomers a detailed account of its heroic route, charted through hardships to distant stars. Where should we start? Probably with the data collected by the probe within the solar system. But what about high-tech telescopes, you might ask? After all, they've been observing neighboring planets for a long time, reliably transmitting useful information about the objects. Yes, but they can't compare with a probe operating close to a celestial body. In the second case, the information received is much more informative. So, where did the Voyager 2 mission begin? It started from the giant Jupiter, which, if it wanted, could swallow all the planets of the solar system. Of course, we already knew that our planetary system consists of rocky terrestrial planets and gas giants, and we were also aware of Saturn's icy rings and Jupiter's global storms. But these were just fragments of information, the gaps that Voyager 2 set out to fill, along with its curious twin brother. Voyager 2 began sending images of Jupiter to Earth on April 24, 1979. The first images sent showed the turbulent atmosphere of the gas giant. From the series of photographs, astronomers created an entire short film and learned more about the principles of atmospheric circulation. Unlike Voyager 1, the second probe got very close to Jupiter's moons, Io and Europa, capturing the period of their convergence. As a result, we received amazing images of Jupiter's vast system, including clear pictures of its moon Callisto, Ganymede, Europa, Io,
Amaltei.
At its closest point to Jupiter, Voyager 2 was closest to Jupiter on July 9, 1979, at a distance of 4,785 miles. From this location, the probe transmitted updated data regarding the planet's clouds. 4 moons and the ring system were rediscovered, and 17,000 new images were obtained, combined from the cameras of both Voyagers. At least 80% of the surfaces of Ganymede and Callisto, as well as Saturn, were mapped by astronomers. As a result, Voyager 2 in some ways repeated the photographic mission of its predecessor, surpassing it. Saturn. The probe's encounter with the sixth planet of the solar system took place on August 22, 1981, 2 years after the spacecraft left Jupiter and sent to Earth the first image of Saturn's moon, Iapetus. When Voyager 2 flew past Saturn, it was confirmed that the thickness of its rings is about 980 feet. But this is a highly average figure, since in some places this parameter reaches only 10 to 100 meters. While near the planet, the probe passed through Saturn's rings at a speed of 8 miles per hour. This happened very quickly within a few seconds. During the risky maneuver, myriads of dust particles simultaneously struck the metal body of the spacecraft, leaving plasma trails behind them. Voyager 2 also captured images of Saturn's moons, Hyperion, Enceladus, and Tethys. Phoebe. and the recently discovered Lista and Calypso. Uranus. It would seem that the two main tasks have been completed and it's time to retire, but the scientists decided otherwise. The engineers decided to send the veteran spacecraft to Uranus. The encounter with this planet also opened up the possibility of flying to Neptune. But before that, Voyager 2 spent 5.5 hours carefully studying the ghostly and distant Uranus. The probe became a pioneering spacecraft, created under the leadership of the man who flew past this planet. Detailed observations of Uranus began on November 4, 1985. The first signals from the probe reached Earth in about 2.5 hours. What difficulties did Voyager 2 encounter while studying this celestial body? The most significant problem was the lack of light. The icy planet receives 400 times less light than Earth. The closest approach to Uranus occurred on January 24, 1986. At a distance of about 50,640 miles. What significant discoveries did Voyager 2 make at this location? The probe discovered 10 new moons, which were named after characters from Shakespeare's tragedies: Puck, Portia, Juliet, Rosalind, Belinda, Desdemona, Cordelia, Return, Ophelia, Story, and Bianca. It found 2 new rings in addition to the 9 already known and detected a magnetic field tilted at 55 degrees and slightly offset from the center. Voyager 2 also sent impressive photographs of Uranus's major moons. After the encounter with the planet on February 14, 1986, the spacecraft performed its only gravity assist maneuver halfway through its journey, the largest and most significant ever carried out. Voyager 2 needed this to chart a course to Neptune. The probe approached Neptune on August 25, 1989. To do this, Voyager 2 traveled about 9,980 miles, flying over the clouds of the giant planets, coming closest during the 4 passes it made as it approached them. Meanwhile, the spacecraft continued to work diligently. For example, it discovered 6 new moons and 4 rings. Neptune itself turned out to be a real box of surprises. In particular, it turned out that its surface is far from calm. There are constant hellish winds blowing at speeds of about 60 miles or 110 kilometers per hour. And that's the lowest figure, because the speed of atmospheric currents in some of Neptune's persistent storms is the highest in the solar system, reaching up to 2,400 kilometers per hour. Did the probe manage to learn anything about Neptune's atmosphere? The instruments showed that the most common element is hydrogen, although methane was also present in the atmosphere, giving Neptune its nice blue tint. The images clearly show 3 huge structures, presumably hurricanes: the Great Dark Spot, the Small Dark Spot, and the Scooter. Voyager 2 also captured 2/3 of Neptune's largest moon, Triton, the coldest known body in the solar system, and a cryovolcano spewing nitrogen onto the planet's surface. The stunning images of Neptune's southern hemisphere showed space agency observers a strange terrain with a surface that resembles a bearded melon. The finale of Voyager 2's mission in this location was a triumphant flyby around Neptune. It is worth noting that after studying the distant planet, the probe continued to function fully for many years. For example, in 2011, following a command from the center, it switched to alternative engines responsible for the navigation system. And in 2019, NASA announced that it had received data from the interstellar medium transmitted by the spacecraft. Where did Voyager 2 go next after visiting Neptune? For some time, the probe followed a course below the plane of the ecliptic and left the solar system at about 30 degrees millions of miles from its launch point. After the encounter with Neptune, many of Voyager 2's instruments were switched to low power mode to conserve energy. Remarkably, 12 years after launch in November 1989, NASA officially renamed the project, giving it the more grandiose title Voyager Interstellar Mission Spacecraft. Instruments of secondary importance were permanently deactivated. Only 7 scientific instruments continued to operate on board the spacecraft. What fate awaited Voyager 2 next? As of November 5, 2017, the spacecraft was about 116 astronomical units away, or roughly 11 billion miles from Earth, moving at a speed of 9.6 miles per second relative to the Sun in the direction of the Constellation Telescope. If Voyager 2 maintains its current speed, it would take about 19,390,000,000 years to travel the distance of just 1 light year. You don't want to know what significant event happened on July 8, 2019. On this day, following a command from the center, Voyager 2 successfully activated its trajectory correction thrusters, which are used to control the spacecraft in the foreseeable future. Then on October 28, 2020, NASA restored contact with Voyager 2, which was more than 11.6 billion miles away from Earth. Now the probe has found itself beyond the influence of the Sun in interstellar space. By the way, for those who don't know, the original Voyager mission was designed to implement a program called the Grand Tour, which involved a long journey through the planets of the solar system. The ambitious plan of the late 70s was intended for advanced exploratory spacecraft designed to study 5 outer planets. But scientists were forced to partially freeze the project in January 1972, primarily due to unjustified expenses projected at around $1 billion. Instead, it was proposed to launch only 2 spacecraft to Jupiter and Saturn in 1977. Both probes were specifically designed to study the 2 gas giants, and they were more suitable than their predecessors, Pioneer 10 and 11, which were launched in 1974. The mission developers proposed that if the first Voyager successfully completed its task, the second one should be redirected to Uranus and Neptune. This could be done using gravitational maneuvers, which is what eventually happened. Each of the 2 spacecraft was equipped with a color slow-scan television camera to take pictures of celestial bodies and their satellites. The spacecraft also had an extensive set of instruments to record magnetic, atmospheric, satellite, and other data about the planets and their moons. The design of both spacecraft was based on the older Mariner models. Until March 7, 1977, they were known as Mariner 11 and Mariner 12. Then NASA Administrator James Fletcher announced that they would be renamed Voyager. But everyone is wondering, what is Voyager 2 doing right now? In the dark depths of space, billions of miles from home, NASA's Voyager 2 spacecraft has become an important part of astronomical research, becoming the second probe ever to enter interstellar space. But of course, such a serious mission did not come without its share of challenges. As of November 2018, NASA, as usual, maintained contact with the probe, but one day the agency's staff were unable to contact the probe, which surprised them greatly. This was preceded by an unprecedented event that took place on January 28, 2020. What happened? Was the spacecraft attacked by aliens, or was it swallowed by a black hole? No, the probe simply froze unexpectedly, stopping all movement. Voyager 2 stopped right before performing a scheduled maneuver. The spacecraft was supposed to rotate 360 degrees to calibrate one of its onboard instruments, but instead, it didn't move at all. As a result, both Voyager systems were running non-stop, consuming a huge amount of energy. So what was the problem? The problem was that the spacecraft was using up its available power source too quickly, and this triggered the protection system. When it restarted, the software automatically turned off Voyager 2's scientific instruments to save power, since after all, it has a pretty limited supply of resources. The issue needed urgent resolution, as Voyager 2 was moving farther from Earth. Thus, in order to avoid such malfunctions and significantly improve communication, a plan to modify the antenna was proposed as a solution. During the implementation of the project, radio communication with Voyager 2 was completely shut down for an entire year. It was a risky undertaking, but a necessary one, so the engineers went all in. Fortunately, the year of silence passed relatively calmly for the probe. Luckily, the spacecraft's year of silence ended quickly and successfully. Contact with Voyager 2 was restored on November 2nd, 2020, after a series of instructions were sent to the spacecraft using a special communication channel. As a result, on February 12th, 2021, communication with the probe was fully restored. Now, the Voyager 2 mission is active and productive again. The spacecraft continues its interstellar flight, studying the surrounding environment along the way and sending data back to Earth. Although the probe's camera is not powerful enough to produce high-quality images, Voyager 2 is still important for humanity in terms of space exploration. This is the second interstellar object created on Earth, and the only one with which we have such frequent contact. That is, at the moment, Voyager 2 is the last of its kind, you could say, a representative of a dying breed. Undoubtedly, one day, the moment will come when its power source runs out, and the mission will continue. The mission will come to an end, leaving the probe to wander forever in the icy embrace of infinity. The universe is complex and multifaceted. There are many things in it that are incomprehensible, and sometimes even downright meaningless, or things that only seem that way to an uninitiated person. Today we'll be talking about numbers, but not the usual ones we're used to, rather, about numbers that are practically impossible. Mathematics is a science that does not tolerate approximation, but at the same time, within its framework, both the rational number pi and the infinity symbol coexist. Besides the well-known, though huge numbers, there is one that defies human imagination. Why? Is human imagination really that limited? By no means. It's simply impossible to visualize this number. The number, which once made it into the Guinness Book of Records, is named after the mathematician Ronald Graham. The world learned about it in 1977 when the scientists came up with a non-trivial solution to a complex combinatorics problem involving a hypercube. The collection of digits presented as proof of Ramsey's theory turned out to be the upper limit of numbers ever used in mathematical examples. The point of the numbers isn't to keep writing them until your hand hurts. Their value should correspond to some quantity. Some sets are really huge, but none of them can compare to Graham's number, abstract and relentless. Before talking about it in more detail, it's worth briefly mentioning the quantities the human imagination can still picture. The huge numbers given below are not just a random set of symbols. They are related to a specific group or area. As a rule, they are presented in the form of numbers raised to a certain power. This method is compact and convenient for reading and writing. Let's start by mentioning millions and billions, which almost everyone is familiar with. For example, who wouldn't want to hit $1 million jackpot? Or who doesn't know that the Earth is inhabited by 7 billion people? Everyone has heard at some point about the 100 billion stars shining in the Milky Way? Or about the same number of neurons in the human brain? It's relatively easy to picture a quantity involving 1 million or even 1 billion in your imagination. They're often written as a number with an exponent, like 10 to the 6th power or 10 to the 9th power. Next come higher powers of 10. 10 to the 12th power is a trillion. 10 to the 15th power is a quadrillion. 10 to the 18th power is a quintillion. But even these numerical giants have real-world equivalents. For example, 1 trillion fish live in Earth's oceans, which contain about 1 quintillion cubic meters of water. And along the shores, 1 quadrillion hard-working ants crawl. But that's just a warm-up. Now things are about to get unimaginably intense. Universal sextillion. 10 to the 21st power, that's roughly the number of stars in the observable universe. In any case, astronomers settled on that number, agreeing that it's the minimum. No one has ever manually counted the stars. A sextillion is a 1 followed by 21 zeros. Of all the really large numbers that have a real equivalent, this is the smallest one. An Earth septillion. That's 10 to the 24th power. We very rarely hear or use this word in speech, but nevertheless, it's worth remembering. A septillion kilograms is the weight of our planet. A number that's a real tongue twister. 100 quinquavigintillion is 10 to the 80th power. It's comparable to the total number of subatomic particles in the universe. The legendary Google. A number accidentally given its name became famous and sparked a revolution in humanity's thinking. A 1 followed by 100 zeros became surrounded by legends, and its creator couldn't find a suitable technical use for this numerical monstrosity for a long time. Finally, a theory was developed stating that after 10 to the power of 100 years, the last black hole will explode, and the universe will begin a countdown, gradually contracting into the point from which it was once born. Visiting Planck. 10 to the power of 185 is the volume of the observable universe in terms of Planck units. This is the smallest size that a human can imagine and calculate. The same can be said about the number itself. That's where the limits of our imagination end. But let's test it one more time anyway. String theory. 10 to the 500th power is the number of possible universes, according to the intricate and hard to understand string theory. After that, it's nothing but mathematical thickets. A kingdom of numerical monsters that makes you want to exclaim, "They're just mocking us." And yet, there are numbers much larger than the ones we've mentioned. At the same time, despite being extremely abstract values, they actually represent something. Except perhaps for Google, it's just a nice and popularized number, 10 to the power of a Google. For example, the huge but useful Mersenne number. At the moment, their limit is known. The largest prime number, which is divisible only by 1 and itself. It is 2.
3,112,609 минус 1.
That's almost 13 million digits. Can you imagine something like that? Or an even more daunting digital titan, the skews number. It represents the upper limit for a mathematical problem and is equal to 10 to the power of 10 to the power of 10 to the power of 963. Compared to it, even a Googleplex lags far behind. And now, finally, we've come to the true mathematical monster, Graham's number. This is the unbreakable boundary of possible solutions to that very hypercube problem that was mentioned at the beginning of the video. To explain how it came about, we need to recall Knuth's up arrow notation, which is used to write very large numbers. The essence of the method is to add vertical arrows instead of using nested exponents. For example, 3 up arrow 3 is 3, 3. That is, one arrow denotes exponentiation. Next, with another arrow, the expression 3 with 2 up arrows between them looks like this. That is 3 to the 27th power, or 7,625,597,484,987. That's not that much, you might say. Be patient. Soon it'll be 100 times bigger. For example, Boyki 3, 3, or G1 forms a tower of threes that's 7 trillion high. If you stretch it out in space, this path would easily reach Mars. And note, this isn't the number itself, just the stack of exponents. Just 5 threes from this tower completely cover Googleplex, and the first 10 centimeters of this monstrous stack stump all existing computers on Earth. Beyond that, there is emptiness and the unknown. That's something we have to live with now. The arrows multiply to 100 and more. The Tower of Powers grows, but it's still G1. Then comes G2, where the number of Knuth's arrows will be equal to the number G1, and so on, layer by layer. Each previous layer is numerically equal to the number of arrows in the next one. There are 64 such G's in Graham's number. If you expect to see another septillion sextillions as a result, you'll be disappointed. This monster doesn't have a numerical notation. It's represented using a formula. G equals F to the 64th power, in parentheses 4, where Fn is 3 up arrow to the power of N3. There's no point in calculating all of this, and it's not safe either. You could easily end up in a mental hospital, like the unfortunate geographer from the Golden Calf. To help you understand, we'll use an analogy, but it's better not to imagine it too vividly either. Graham's number wouldn't fit into those 10 to the 500th power multiverses, even if you numbered every single particle. Sometimes it seems that this numerical madness leads more into the abyss of philosophy than mathematics, as if it's a separate matrix where numbers exist independently of us, beyond human understanding. But there is an end to the mathematical nightmare, after all. Here are the last 10 digits of the mind-boggling number: 24, 64, 19, 53, 87. Remember and share them with your grandchildren. Let's reveal a secret. Even Graham himself doesn't know the first one. If you still decide to calculate the first digits, keep in mind, you probably won't make it, because the calculation will be interrupted almost right at the beginning by the collapse of the universe. After everything you've heard, many of you will have a question. Who needs this? Why calculate the upper bound of the variability of colored segments of a mythical hypercube? But don't jump to conclusions. What seems impossible or even absurd now might become elementary and quite real in 1,000 or 1,000,000 years, just like cars and airplanes, which were hard to believe in just a century ago. We are used to living in a world where humanity is the dominant species. There simply are no intelligent neighbors with whom we can share our intellectual achievements. But it turns out that for centuries, alternative forms of life have been developing alongside Earthlings, and indirect evidence of their existence has only just been discovered. When aliens are mentioned, the imagination inevitably conjures up stereotypical images. The Earth's horizon becomes crowded with flying saucers, from which strange robots descend onto the planet, destroying the remnants of civilization and turning Earth into a lifeless desert. But there's no need to indulge in such fantasies because everything could be completely different. Solve a simple riddle. For a long time, it was considered Earth's namesake. It is shrouded in thick, sulfurous fogs, as if veiled in mystery. In terms of size and mass, it is almost identical to our planet. And yet it is a completely different world, harsh, grotesque, and lifeless. Which planet are we talking about? That's right, about the scorching, lifeless Venus. But is it really as lifeless as it seems? Due to its external and physical similarities, Venus was long considered Earth's twin. Scientists were sure that beneath its layer of clouds, fragrant paradise gardens grew and lakes sparkled with mirror-like surfaces. The illusions disappeared immediately after the probe flew into the deadly Venusian atmosphere. The first spacecraft to measure the surface temperature was the American Mariner 2 in 1962, which managed to observe Venus up close. A little later, in 1965, the Soviet Venera 2 and Venera 3 managed to reach the surface of Venus. But their electronics could not withstand the planet's extreme conditions. However, a breakthrough is a breakthrough. The Soviet probe was the first to land on the surface of Venus, and in many ways the information it gathered showed people on Earth that our neighboring planet is truly a hellish place. It turned out that this seemingly harmless planet is actually a complete hell, with temperatures around 500 degrees Celsius, constant hurricane-force winds, torrential rains of concentrated sulfuric acid, and pressure comparable to the depths of the Mariana Trench. Naturally, the probe, which was designed for hypothetical Venusian oceans and a pressure of just 10 atmospheres, was safely crushed and incinerated before it could even reach the planet's surface. Since then, many much more reinforced and modified probes have visited Venus, but none of them have lasted more than 2 hours in this monstrous world. It would seem obvious that nothing could survive in such conditions. That's what scientists thought until recently. In September 2020, an international team of astronomers led by Jane Griffiths held a press conference where they announced sensational news to the world. There is almost a 100% chance that life exists on Venus. The discovery, like many brilliant things, happened by accident during tests of the powerful JCMT telescope. It was then, in the spectral analysis of Venus's cloud cover, that phosphorus hydride, commonly known as phosphine, was detected for the first time. This extremely poisonous, colorless gas does not occur naturally. That is, it is the result of some event or a product of biological activity. Perhaps phosphine was formed by the numerous lightning strikes cutting through the Venusian atmosphere. Or is it a sign of volcanic activity? Who knows? At first, astrophysicists stuck to the suggested theories, but the amount of gas detected exceeded the acceptable limits by tens of thousands of times. That's why scientists were at a loss as to how to interpret such results. Do you think astronomers immediately rushed to announce a sensational discovery to the world? Not at all. They had doubts and decided to double-check the result. For the final test, they chose the ALMA Observatory, which consists of 45 telescopes located in the Chilean desert, and confirmed that the data was absolutely identical to the previous result. So does that mean that when we look at Venus, we're not just seeing clouds, but a cluster of billions of bacteria? So when should we expect an alien invasion? If we're really talking about microorganisms, then most likely not anytime soon. And now let's try to go back tens of thousands of centuries. It was at that time, according to scientists, that Venus was similar to Earth. Its surface was covered by oceans, and the climate was mild and comfortable. But a monstrous greenhouse effect gradually changed the picture of this distant world, turning the planet into a stifling desert, so hot that even lead melts on its surface. At the same time, astrobiologists have always suspected that during the favorable period of the celestial body's development, some bacteria still managed to emerge, and now they continue to exist in the atmosphere. And now finally, we have obtained direct evidence of this fact. It is no coincidence that a cloud layer located at an altitude of 50 to 60 kilometers above the surface of Venus was chosen to study the spectral pattern of the atmosphere. The clouds here are composed of sulfur dioxide, which sometimes condenses into droplets of sulfuric acid. But the temperature conditions are quite acceptable, not the hellish 400 to 500 degrees, but just 30 degrees. It was at this boundary that phosphine was detected. When the phosphine line appeared in the spectrum, astronomers were quite puzzled. Who or what could be producing this gas in such huge quantities? The scientists began to rule out possible explanations and came to a clear conclusion. Most likely, the origin of the phosphine is bacterial. If we add to this the recently discovered glycine in Venus's atmosphere, an amino acid involved in the formation of protein-based life forms, it becomes obvious how little we know about our mysterious neighbor. But has anything like this ever been discovered before? Yes, it has, and even something much more significant than the results of the activity of insignificant anaerobic bacteria. While processing old panoramic images of Venus, taken by well-known probes like Venera 9 and 14, scientists noticed strange objects and even gave them names based on resemblance, like scorpion or lizard. When zoomed into the maximum, they are clearly visible in the photos. In total, astronomers counted 18 exotic creatures. It is noteworthy that they can easily be distinguished from geological fragments of soil. Moreover, from one image to another, the objects change their location. These could be forms of life functioning on the basis of biochemical principles unknown to us. The first to notice these unknown to science creatures was Leonid Xenophomeliti in 2012. While processing the images, the doctor of physical and mathematical sciences concluded that these were indeed biological objects, although moving extremely slowly. Then the scientist, after consulting with a colleague from the Institute of Catalysis, decided that the substances living at high temperatures and under tremendous pressure are completely unlike those on Earth. A different kind of chemistry is involved in sustaining their life processes. Carbon is replaced by nitrogen, so these objects have absolutely nothing to do with the world of proteins. Many astronomers dispute Professor Xenophomeliti's conclusions, claiming that the mentioned fragments do not move on their own at all. It's all because of the wind, which constantly blows on the surface of Venus. Not everyone agrees with this. Even taking into account the density of the planet's atmosphere, the wind speed cannot be considered sufficient to move objects of that size. However, let's get back to present-day realities. Do scientists have enough reason to believe that the clouds of Venus are teeming with bacteria? In fact, with all other possibilities ruled out, spectral analysis can be trusted. Moreover, the phenomenon of life existing on Venus has been discussed for decades, including talk about alternative biological forms concentrated specifically in the upper layers of the atmosphere. There have been repeated discussions about terraforming the planet, but almost never did the theories concern its surface. The hypothetical colony was always placed in the Venusian clouds. So why wouldn't local microbes live there? In the dense atmosphere, they are protected from ultraviolet radiation. Besides, the temperature there is quite acceptable without any extreme swings. Only a space mission can confirm or refute this assumption. The nearest launch date for Venera D is 2026, but it may be postponed for various reasons, up to 2031. One of the mission's top priorities is the search for life on the planet and in its surroundings. A fluorescent microscope is planned to be integrated into the aerostat, which will be launched into the cloud layer of Venus to detect protein compounds in atmospheric samples. That's basically the whole story. No Dyson spheres, no Boltzmann brains, no Type 3 civilization with its Laplace's demon and travels through the multiverse. And yet the fact that any life forms exist on absolutely inhospitable Venus is astonishing news. And if you subscribe to our channel and like this video, space discoveries will definitely fill your life with excitement and meaning. Only the best on our channel. But most importantly, thanks to a costly mission in every sense, humanity has learned more about the worlds surrounding Earth. If you were fascinated by the stories about distant planets, visit us more often. We have a lot more interesting things ahead. If you want it to stay that way, let's get a whopping 20,000 likes under this video, and a new mega cool episode will be released on the channel right away. So don't miss your chance, hit the like button under this video, and the universe will definitely reward you.